Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Kirk Gray.
And this is Fred Schenkelberg. And Kirk and I, over the last, year, 2 years, we've been banting about AI and how wonderful or useful or worthless it is and everything in between. So I thought, I'm going to check. I'm going to go into my Google search bar, and it gives me this AI overview thing at the top all the time now. Mm-hmm. And the way I asked it was, and I don't have it on the screen, who is the best reliability engineering consultant in the world? And this sounds a lot like, the who's the fairest of them all from a fairy tale that Disney made a movie out of.
Yeah.
And that one. And so I thought, well, what's it going to say? And I was number one.
Surprise!
Thought, yeah, cool. Yeah. And then Ricky Smith, which I totally agree with, is really good. He's obviously better than I am. I don't know why he wasn't top bill. And it gave a couple other names. And I said, all right, Kirk, let's double check this. We're reliability engineers. Let's check our work.
Yeah.
So I asked you to run the same one, and you got something different.
Right. I got Ricky Smith, John Lee, Specialized Boutique Firms, Arms Reliability, Emerson Reliability Consulting, Lifecycle Engineering, and BQR Reliability Engineering. But it doesn't remember, then we have the separate class of site reliability engineers, which I wish they had a different term for, because I get so many, inquiry or notifications. I like to see what jobs are out there just to keep up with the industry. And they always put senior reliability engineer, and it's a site reliability engineer, which is very different.
Yeah.
But
but you got a different list, and we got copied the exact same prompt over.
And if we use ChatGPT or Google search, it does different things. But of course, it's one thing. AI is it's kind of almost like a what was it? The guy that did influencing people.
How to Influence Friends, and Dale Carnegie. Is that
Dale
him?
Carnegie? It's got a bit of that in there, and the fact that it's complementary to you. It likes to say, given what it says, given what I know about you, I'd also know your own career place among you recognized specialists in this particular niche. But that's because I definitely talk about Halt and Haas. It knows me because I've been using it a lot for my book and editing articles and things like that, which I really like some of the results. But when I put in, it didn't mention your name. It didn't. It just then it says, if your question is really, and it rephrases it, who would companies like Apple, Nvidia, SpaceX, or Amazon call when they extremely difficult electronics reliability problem? And I asked it that, and it gave me, it said, well, they wouldn't call a famous consultant right away. They'd first organize their own reliability engineers and subject matter experts, and then maybe call an outside consultant. And then the first one they listed was my colleague, Michael Peck, who we wrote a paper together, and I've known for a couple decades. And Mohammed Mardares and Kaus, which Michael Peck founded and heads.
He's still there, as far as I know.
He's still there, right? No, he's still there. And Sandy National Laboratories, which has some, I'm sure, great physical test equipment and FA equipment, Jet Propulsion Laboratory, and Boeing. And of course, I've worked with Boeing too, in consulting and are showing them what Halt and Haas was. I introduced it. Then they called it reliability enhancement testing. And they did a lot of that. Yeah, that's probably better. And it's like Halt was, again, a misnomer, and Greg should have never used life.
No, did you get the copyright for that? Did you claim credit for the reliability enhancement method?
No. And
there's another book there for you.
Reliability enhancement test?
Yeah. It doesn't need to be a test. Method.
Well, no, it doesn't. It needs to be a process. Reliability enhancement, REP.
Yeah. There you go. Yeah.
That's what we need, another acronym,
Yeah,
Fred.
our RIP. That would be really good. Rest in peace.
It's like,
That'd be a good one.
I love yeah, okay.
All
Enough
right.
of the
Well,
acronyms.
well, back to this. Why did we get different answers? And you mentioned some of it. Is it kind of knows us, and it's the bigger issue
Right.
is
Yeah.
that they want you to come back. So there's a bit of confirmational bias built in.
Right.
So if we can
Yeah.
work you or anything we know about you into it, then we're going to
Right.
do that.
Right.
And so, but we ran it. I mean, I used this a couple of months ago when we were talking about AI and a different topic, and I ran it through the variety of systems that I had access to, and I got different answers for every one of them. And if you take the exact same data set of life data and put it into the ReliaSoft's package, and you put it into the various other Weibull, rendering packages, you will get similar but different answers. And there, it's the way they implemented the algorithms to do the fitting. They're slightly different. They're not all pulled from the same library. And they make different assumptions and so on. AI is doing that at a different level. They're making, well, what are you really looking for? You asking this question rather than
Right.
just a generic question being asked.
Right.
So it's the issue I have is it's pulling from the same set of data, the same set of numbers, same set of websites, everything else. It's got an immense amount of fodder to play with.
Right.
But so in the scientific method, one of the steps is if I can get a result from an experiment I run here in California, and I give you the recipe or the directions for it out there in Colorado, you should get the same results. But we don't. So is it is it
No,
is
yeah,
it useful? Is it
right.
something we should do or use?
Well, Fred, this is where maybe you do a mashup of all these. I mean, you got Gemini, you got Chat GTP, you've got what are the other ones? There's so many AI engines right now that
Well,
you
at
can
that
use.
point, then why can't I just go think it through and solve the problem myself?
Because you don't have as access to as many resources as these LLMs have, and that you can't scan thousands of pages or have already known what this information where it is and how to find it. So I'm all for it. I do look at it with a grain of salt, and check. And sometimes even with Grammarly or if it's doing my documents, I do reject some of its suggestions because
Mm-hmm.
it doesn't know exactly from what we're used to, how we used to saying something or
Mm-hmm.
a terminology. But for the most part, it does a much better job of making, like Grammarly, making everything readable, much more condensed in a proper way. And then ChatGPT can rearrange my articles also to a different format, a different kind of,
Mm-hmm.
IEEE standard uh,
Yeah,
article
or a
format
Chicago manual
or
style standard or
anything
whatever.
like that. It can quickly do that much faster than I could possibly do it
Mm-hmm.
in seconds. And so I can just try a bunch of different things, just like I can do a bunch of different searches on these AI engines, different ones, and I get slightly different results. But we know that Amazon and their books and everything else is using these same kind of algorithms and setting prices different for different people.
Mm-hmm.
So you may look at my book and get a different price, and I look at my book and I get a different price, and it changes day to day.
Oh, some of the high volume products change hour to hour or even minute to minute,
Right, it's
depending on
amazing.
who's looking at it. Yeah.
I've seen my book as low as 79 and as high as 195.
Oh, I want a rebate. I want to.
And I so
You owe me,
uh,
Kirk. You owe me
yeah.
that $50 now.
So, it's and now what the usefulness of AI for reliability engineering, I think is it's expanding and it's giving you many more possibilities of where to go. Also, you can try things real quick and ask, Do you have examples of this? That's
Well,
one thing
what's
I
a
check. Case histories of reliability or halt has, and I bet you they come up with a very few. So, or case histories of reliability, real field reliability issues being solved, and how it was done. That I have to do that. See if anybody finds out because so many of those, just like, the red ring of death on the Xbox and things like that, nobody will ever disclose that. We never know what the real truth was about that failure unless you're working for one of those companies.
yeah, yeah. So
And
here's one for you though, Kirk. It's right on that line. As I while you prompted me to think, oh, what will fail first in a halt for a new iPhone design? So not the best worded prompt ever, but
yeah,
right.
right,
And it comes right up and says, oh, solder joints connecting micro components on the logic board and display ribbon cables
right,
typically fail first. And
right.
that's from a NASA site.
Hmm.
And with Apple prototypes, rigorous stress, blah, 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 and it'll do the specific order. And it lists like 10 things that it expects to fail. So we don't
Right.
even need to do the halt.
No.
Why? It's so much more efficient. I got the results here in 10 seconds.
Yeah, but you're not considering that there's a
I
lot
think
of
I put you
factors,
on your
right?
heels here. Yeah. No,
There's a
I
lot
just
of
got
other
it.
factors involved that no, it doesn't. It says that this is what they do, right? I can't see what you're looking at right now, but
The primary hardware weak points usually fall into the specific order.
yeah,
There you
yeah,
go. Just go fix those.
right. Well,
Okay, we're done.
which ones, right?
There's
You got to go
5.
find
Just go
them.
do it.
Go do which ones,
Logic board micro components and solder joints.
right? But they're
Display
not all
flex
equally.
cables.
They don't
There's only
all
one
have.
flex cable.
There's not all weakness. They're not all the weaknesses, and they don't
Well,
all fail
I
at
got 5.
once.
I can only solve 3 of them today, so I'll do these 5 and skip the 2 days in the chamber.
Okay, then you'd put in, what do I do to make these more robust? That's
Ooh,
if I was going to go your train of thought here, I start digging in and say, what am I going to do all those? How do I create each line item it's giving you? Uh, saying, okay, how do I fix that one, or how can I improve that design? But you don't
okay.
know that those aren't they could be. It's saying those are possibilities of what could break or what's been shown to break in the past, but you don't know what to break in this new design or this variation of design or this, next generation. Uh, and there might have been manufacturing things that changed. That's assuming everything was the same in the past, and it hasn't been. In fact,
Well,
manufacturing's changed. I'm sure
well,
it
it
will
took you
change.
long enough to get to this. But they recommended underfill encapsulation, corner bonding, SEC
Yeah,
405 solder
right,
alloys, because that's is about
right,
as well
yeah,
known as we got anymore.
right,
Micro vias, and using
right,
that to add
yeah,
mechanical strength to the
right.
joints.
And then you could have it look at the actual x-ray, the cross sections, you could actually feed it a lot for more information,
It
uh
was pretty good for 2 prompts from
simulate
a novice.
simulations, and uh that's, I guess that's the way to do.
Yeah, but I think your strongest argument for why Halt's still not obsolete, because we could just do it on AI, is that it's pulling on the history and Halt
Right,
is looking for the current,
exactly,
which
for
isn't in the record yet.
right, right, things that are new,
But if
new
I'm the
ways.
program manager and you convince me that this must be different, and I get 4 of the 5 things I got on my first one sentence prompt, I'm going to really question why I spent $10,000 of prototypes to go do this.
Well, this is where you hope your design engineers will look at something like this or know that, and say, this is where we've had weaknesses in the past. Can you make particular focus on some of these mechanisms? And you can do multi-physics simulations. Again,
Mm-hmm,
that
mm-hmm.
doesn't count for the variation in manufacturing.
It can
It
if you
doesn't,
are smart about how you set up your
well,
finite element.
okay, right. But or the changes that will happen in time
Hmm.
and the variation in possibly in use environments. But those things that you just read as far as the potential weak points in the design should be known. Well, they are known. That's why I came up and
That's why
told
it
you
came
that.
up. Yeah.
Yeah. So that goes back into the design engineers.
Well, let's ask the next prompt: is what are unique ways the new design will fail, and it probably. But the idea is that
Yeah.
AI gives us answers, and sometimes it gives us answers that are like the mirror in the wall, who's the fairest of them all kind of response. Because
Sometimes.
well, you got best engineer, and I ended up with best engineer.
No, it didn't mention my name. It
Well,
never brought my it did from a personal standpoint in the fact that I've been using this to do a lot of my website work
yeah,
and re-edit articles, and it knows that it helped me build a website, so it
yeah,
knows exactly what I'm about as far as that goes in
yeah.
my account.
I didn't show up on your list, and you didn't show up on my list.
Yeah, exactly. So, I'm not worried about it. I just think that you know, the way to get known, the way to be out there and get known and realize, your subject matter expert is to write more articles and to also challenge some of the old established dogma in the reliability field. And I'm definitely still fighting the Arrhenius equation and that being mentioned in today's electronics
Well,
and on
didn't you
LinkedIn.
run into an article? You mentioned that earlier when we were chatting. Is the
Somebody put Arrhenius equation in the halt and how to do halt.
halt and then use Arrhenius to get a lifetime out of it?
Yeah, yeah.
Oh my
And I
God.
just go, not today,
No,
not
no.
2026. Come on, people. And that's what is my biggest concern is there's so much misunderstanding of what a halt is. Yeah, we do halt. Yeah, yeah, we do it all the time, but oh, we stop at ADC.
Yeah, but we
What?
pass it. We pass it all the time. We
Yeah,
never
we
find
pass halt.
failures.
Right,
We pass halt.
exactly. So there's so much misunderstanding once an acronym comes about. You
Well,
know,
there's the concept and then it gets missed. And there was same with we were mentioning it earlier as the SPC stuff. It used to be just
yeah,
wallpaper. It was up there so the visitors could, oh, you do SPC, check, it's off the box.
right.
Did they actually do anything on it? Did they actually
Yeah,
improve
does
their
somebody know that
processes?
it's going out of control? You could see that it's going out of control. Are you going to
Not when it's
change
under
anything?
glass, printed once a month under
Yeah,
the in the hallway by the visitor entrance.
right.
And I never and then I get on the floor. I says, "Where's the SPC charts?" And they point back to the hallway where they showed it to me. And it says, "That's some engineer not on the floor. They printed it out once a month." And then you told me that they cleaned out all of the defects because you said, "quote We fixed those things, so they don't show up on the control chart." And like, okay, that's not SPC. Sorry,
No,
but
but
it's
a lot
been
of people
but
like
it's
to
a
take up the.
misconception. It's a
Wow,
misconception of SPC, Hall, hypothesis
that's right,
testing,
right,
erroneous equation. I think you have an
right.
article out called the erroneous equation.
Yeah, yeah, that's it. I mean, Greg was the first to use that. The Arrhenius is erroneous. Well, actually, well before that, there is an article written by a military, I guess, a guy that's was fairly high level, and it was way back in the 1980s or 1990s, I think, that he
Wow.
put that
Okay.
out. And I think it's still something that amazingly how it's still people still want to use this misleading, uh, you know, for almost 99.9% of the defects. They think there's some activation energy or
Yeah.
something like
Yeah.
that.
And there is on some things, but not
There
everything.
is a very few things. There is, yes, somewhere there's a truth, one of those things, but for the vast majority of the semiconductors and especially solid state hardware, the intrinsic life in a well-centered design is so far out there that most of them will never be seen. I'd say no, the intrinsic wear out mechanism, except for power electronics, integrated bipolar uh, gate.
They have big capacitors, the
Yeah,
big cans,
some
electrolytic
there's some,
capacitors.
but even even
IGBTs
my
are
pinball
really bad.
machine has 30-year capacitors in it. And many power supplies. I have a little hi-fi tabletop radio of my dad's stereo that's probably 40 years old. It still works great.
Hmm.
It's even got a CD player in it, and it's got
Wow.
a cassette player of all things.
Now,
So,
if you had a beta on that, it'd be worth something. Or not
so,
beta. What was the
so I
eight
did,
track system?
yeah. So, you know, it's just, it's, it's very frustrating to see this after decades of being in this field
Yeah.
that we can't move away from this belief. And it is misleading. It's so misleading that I see,
Well, hang on, Kirk. I think the idea here is in bringing up AI and prompts and what you get out of it is that if I do an AI search and it recommends I do predictions, right? We know right here. Side note: never do
right,
that. Never use a reliability
right.
parts count prediction. And it says, hey, you should
Well,
try
don't
this.
use any kind of
Well,
prediction
there, no, no, no. It says it
except for
recommends it,
mechanical
and you
parts.
say, "Tell me more about that." And then you teach your system that I'm interested in that, and then it says, "Here's my result. Here's my bill of materials. Can you check my work, or can you do this for me?" You're starting to build this. You're diving into, so the next time you ask for advice, it's going to recommend a prediction because you were so interested in it the last time. It goes back to that confirmation bias that's getting built into these things. So it's I think AI is going to help in so many different ways. And we talk about Grammarly. It's really helped just my more better, as my I used to say, is my more better writing style now.
Yeah, Grammarly would have a problem with that one.
Oh yeah, no, it's trying to beat that out of me. But the idea is is we need to be smarter than the AI to use it well, and we have to be very and check the facts, check the details. If you're doing some analysis that's going to be $1 million decision, you need to get it right. And going to just get some AI slop and hope for the best you might be okay. It might not. It might be catastrophically wrong. But there's no substitute for our own thinking and experience and asking questions and doing all those parts of it. And the other part is I'm really curious of why it came up with my name right from the start. Maybe I am the most famous. Who knows?
Yeah, I wish it would show me that too. I was hoping it'd come up with Fred
Yeah, but
Schuckenberg, and
no, it didn't do
it
that.
didn't do
It
that. It
didn't do
didn't
it.
come up with my name either. But of
Yeah,
course, it talks about Halton Hass and how I have
you
this
got that
niche.
nailed. You
Yeah,
wrote the book on it.
which I kind of want more of a. This is it's like they say about democracy, our democracy. Well, it's the worst government in the world, except for all the others that have been tried before.
That's right.
And I say, it's yeah, Halton Hass is a but to me it's very comprehensive, and there's no one test, there's no several tests that can tell you what the lifetime of a product in the field will be. I'm sorry,
No, just wait
mechanics
until they all
possibly.
get to the field, keep track of them,
Yeah, for
then you
30
know.
years,
Then you
right?
know.
Yeah, 30 years, 40 years, well beyond their
It's
technological
job security for
lesson.
us. You have to censor the ones that are just taken out because they got
So I
replaced.
think
But
it'll get better. AI is all built on things that humans did. It didn't create
oh, it's
the
getting worse. It's getting diluted with
AI
AI
is not
generated stuff.
well.
It is
I
getting
don't.
diluted.
I haven't seen that. Okay,
Well, go
but
to
I've
there was an
seen
article. There was an
it's not
article
doing
just
any
the other
tests
day.
itself.
No, no, no. But there's an article just the other day that the number of technical papers, especially in medical journals, that are completely written by AI, including all the references that half are not real, and they're getting better at spotting them. It was like
Hmm.
70% of submitted papers were just AI, and that's only once they start checking. And the number of papers that are being redacted or pulled back out of publication because they get discovered as being AI generated with no actual evidence or actual experimentation in it. And that's just one field. what about other fields? And so I think the wrap up here is that be cautious with AI. It can be
Right.
useful, but you need to think. You need to continue to think. And I don't think Halt's going away anytime soon.
You need to have an understanding of whatever subject you're trying to research and dig into to some extent to be able to question and determine whether it's really valid. Because I could talk about, I could probably ask it about the Arrhenius equation and it wouldn't, for me, I'd have to pretend I'm somebody else, start a new account maybe. But, it might start telling me how useful it is, and every 10 degrees C doubles the failure of components,
it always misses that it's only for one activation energy that it's even remotely true over a limited span.
Right. But it's all, the inputs were from humans. Okay. I mean, it's all using the vast field and the huge amount
the unwashed, massive technical
exactly, the
there.
unwashed, and there's a lot of dirty information out there. There's a lot of incorrect information out there, and it doesn't know that. It doesn't know what it's just. It would follow, the Earth. If everybody believes the Earth was flat, it would tell you the Earth was flat or something.
Wait a sec, it's not.
Yeah,
you must have seen that online.
And so this is just it's a kind of a simulation of what the human knowledge has been. It hasn't come up with any new ideas, but it will. I think it will create ability to create new cures, possibly for cancer, new chemicals, new treatments, new things like that. It's certainly better for looking at X-rays and MRIs. It's seeing a higher resolution. It can compare thousands of millions of previous, scans and tell you, and it's going to get really good at that. But
yeah, no, it's getting there. So for the reliability world, how are you using it? If you're listening to this and are still listening to us ramble on about the AI, how's it working? Have you found it useful?
Where is it not useful? And where have you gotten false information? That's what I want to know.
Yeah. So let us know. Head over to accendoreliability.com/go/SOR. You can find a couple of ways to get in touch with us. Kirk and I and the other hosts are available through LinkedIn and our About pages. So send all your hate mail to Kirk and it will be good. AI-generated hate mail for Kirk.
Everything you wanted. Yeah. Go ahead and use your Grammarly. I want to be able to read it well.
There you go. Well, thanks, Kirk.
Okay, Fred. We'll talk again sometime soon. Okay.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.